we will talk about the superposition theorem. We will do this through an exercise, and I'll use the example, which is example 9-1 from the Circuit Analysis 5th edition by Robbins and Miller. And I'll re-explain again exactly how they solved and demonstrated the superposition theorem. So the circuit started out in this manner, where we have a combination of sources. We have a current source right here, and we have a voltage source right here. So this was a 20 volt, and this was a 2 amp I. And let's complete the circuit towards some sort of a load right here. And this was RL, and that was a 16 ohm load. Okay, and this happened to be a resistor here. Let's call it R1, and that was 24 ohm. Okay, the point of this is they wanted to find what is the current IL going through the load. Okay, so they did this in 2 steps. Okay, so you have 2 types of sources. You have a current source and you have a voltage source. So 1 step for the current source, 1 step for the voltage source. There are rules with each step. The superposition means you're going to superimpose one equivalent circuit over the other. So we'll start with the first equivalent circuit. Okay, so we're going to, let's call it A. And what you would do if you have a current source is that you will open it as if it's not there anymore, not short, but open. So your circuit is going to look like this, R1. You will leave the voltage source in place. And now your RL is right here. That means you still have some sort of a current here, right? It isn't really this IL, but it's parts of it, considering that what we did is we took out the current source and left it open. So we left this point from here to here open. Let's call this one IL1 or partial IL1. Okay, now for this one, pretty much IL1, we could see that IL1 for this one will be equal to E divided by the sum of the resistors, right? So R1 plus RL, which is your 20 volts, divided by 24 plus 16, and pull my calculator here a second. Well, it's about 0.5 amp. There you go. Okay, so now, part B. This time, you will leave the current source in place, but you will short the voltage supply. So there, here's our short. Keep R1 here if you want. Now you have a current source, and you have your RL. So this one will be your 2 amp current source. You have RL remaining here, but we're interested this time in IL2, which is the partial current that will make up IL1, and IL2 will make up IL. Okay, so when you look at the circuit like this is equivalent to saying, okay, well, what we have is something like this. I'm just going to draw several circuits so you're comfortable with the configuration. This is not any different. So this would be R1, this would be RL, and then this will also be equivalent to the current source being here, and these two resistors in parallel. So your RL is right here, your R1 is right here, and your I is right here. So we could use the current divider rule to find the IL2 going through RL. So IL2, okay, will be equal to the main current times the other resistor, right, divided by the sum of the resistors. Okay, so R1 plus RL. Okay, so that would give us 2 amps times R1, which is 24, divided by 24 plus 16. And that's going to give us, now remember, in our case here, the current is really going the other way. So watch how this current is going this way versus my starting point. So we know the two partial currents are going to go this way. So this is important. So what I have here is really a minus. So just make sure you see that minus in there, because this current here is opposite to IL2. So this is your IL or your minus IL2. So this is going to give me minus 1.2 amp. Okay, so now out of these two, we want to deduce what is IL. So IL typically will be equal to the sum of the two, right? So, but in this case, since the other one is negative, so you're going to get your 0.5 minus 1.2, right? So you're adding them up, and you're going to end up with minus 0.7 amp, which technically says, that's great, that's your IL, that's your final IL. Really, the current is heading in this direction. This is the true direction for IL. Okay? But the point of this exercise is you were able to find the load current by using what we call superposition theorem. So the point again is you're going to have to work with equivalent circuits. You will keep the voltage sources first, open up the current source, short the voltage source, and install the current sources back in.